Hello friends, welcome to my channel Electrical Master. This video we are going to discuss about cable sizing calculation for MCC panel. So this video is one of my existing project I have done in my company. Actually I find the cable sizing for connecting to this MCC panel from this transformer. So I did as per the IEC standard how much cable size is required for connecting this MCC panel from this transformer. And also this video we are going to discuss about derating factor of the cable, voltage drop, and how to calculate short circuit current. So let us go to the video. Before going to slicing the cable as per the IEC standard, you should know these three condition is very important. The first is cable derating factor capacity should be greater than system full load current. And second, cable voltage drop lesser than 3%. And third, cable short circuit current capacity should be greater than system short circuit current capacities. So these three conditions, if it is satisfied, then our cable is sufficient. So now we will see, this is my project. Actually this is the MCC panel taking power from the transformer, and this distance between this transformer and the MCC panel is 25 meters. So my client requirement is they want to connect the underground cable, and they have maximum allowable size is 240 square mm. So I have to precise the cable how much mm is required, and also how many numbers of cable is required for that connecting this cable from transformer to the switchgear. Okay, if you are seeing the transformer details, it's 11 kV by 440 volt, and transformer full load current, primary side 83.5, secondary side 2021 amps, percentage of Z equal 6.25, vector group dy and 11, and this is the short circuit capacity of transformer 30 kilo amps. And if you are seeing the MCC side, it's a capacity of load connected in the MCC panel is 555 kVA and 440 volt switch MCC panel, and full load current of this MCC panel connected load is 729 amps. And this MCC panel having connection of two incomer, two same identical transformer is connected, bus E and bus B section. So that is one we need to find how much cable is required for that. So let us go to that sizing calculation. First, that we know that as per the vendor details, full load current they have for the MCC panel is 729 amperes, and our selected cable capacity should be greater than this 729 ampere. That is our requirement. And also the client suggested they can maximum size it could be used in that MCC panel is 240 square mm. So that is our maximum limit for the cable sizing. So what I did, I just checked the 240 square mm 4 core XLPE cable from the cable data sheet. That base current of this 240 square mm 4 core copper XLPE cable is 514 amps, and without considering derating factors. So the base current value only 514 amps. So what I did, I just select this same current value. Based on that, I find how many cables is required. Number of friends required equal to, so full load current 729 ampere divided by this cable current carrying capacity 514. It came 1.4. So round up the value 2 numbers. So 2 numbers of cable is sufficient for connecting transformer to the MCC panel with this load. But only thing is, I did not consider any derating factors. So now I go to the as per IEC standard. This is just a cable data sheet. You can see here 240 square mm 514 ampere is base current value in ground connections, underground connection. Okay, so as per the IEC standard, I have to consider the derating factor. After derating factor, that current value should be greater than the system full load current. That is the first conditions. Okay, so system full load current 729 ampere, and selected cable size is 2 run of 4 core 240 square mm copper XLPE armor cable. Okay, Now we will check this ampacity rating. Ampacity rating, as per the IEC standard, there will be two things. One is for the above ground connection, underground connection. Here I am using only underground, but also I just explained what is above ground. Above ground means if you are connecting cable through the transformer to switchgear through the cable tray, that is the above ground connection. Okay, cable tray or conduit, that is the above ground. In that condition, you have to consider only two things. One is the ambient temperature and also grouping factor. Ambient temperature, normally for the above ground they are considering 40 to 50 degree as per IEC standard. And grouping factor means, suppose if you are connecting 2 or 3 runs of the cable, means how many distance minimum keep between that cables, that is the grouping factors. Okay, so see here in that underground you have to consider 4 correction factor. That is the ambient temperature first, K1 40 degree, and soil thermal resistivity. Thermal resistivity means you are installing cable directly into the ground, so there will be some temperatures. Thermal resistivity will be in that soil, that will be need to be calculated in that correction factor. So as per the IEC standard, you have to consider 2 km by W. Km means Kelvin meter per watts. Okay, and depth of cable laying, how much depth you are digging in the ground for installing that cable. As per that IEC standard, minimum depth for the low voltage cable is 1 meter. And fourth is grouping factor, same as I told, it's a 150 mm. So we know these details, but we don't know how much values for these details like soil and thermal and grouping. And these values you have to refer only in which cable you are choosing, that cable manufacturer datasheet only you have to refer, not IEC standard. IEC standard you have to only consider these values. So particular details about these values you have to check in the manufacturer datasheet. See here, this is the manufacturer datasheet for the cable. So ambient temperature, directly installing cable in the ground, 40 degrees Celsius, it is given in the IEC standard. For that 40 degrees Celsius cable value, it could be 0.85. okay, so in the ground temperature 40 degrees Celsius, that cable value it will be 0.85. Similarly, soil thermal resistivity, IEC value is 2 km per W, that IEC value is 2 km per W. And cable value you have to check, thermal resistivity 2 km per W, and 240 square mm cable, you can get it in the datasheet 0.80. okay, similarly depth of cable laying 1 meter as per the IEC standard. So depth of cable laying in ground, how many meter, this is the meter values, so 1 meter. And cable laid directly in the ground, distance cable between 70 to 300 meter, 300 square mm means you have to choose these values. So you can see here both values meet here, 0.93. so depth of cable 1 meter is 0.93. Similarly grouping factor 150 square mm. So grouping factor of the multifocal cable, so how many cables we are grouped, we are choosing 4 cable and 15 centimeter, that is 150 mm. So 150 mm means 0.74 we considered. So now we got it all the grouping 4 values. So those values we need to multiply with our cable base current, that is 514. So base current value without consider any derating factors, so that value multiply with all these correction factor, you will get 243.5 ampere. Now you will see without derating the cable value is 514. After consider all the derating correction factor, temperature correction factor, value reduced to 243. Now after derating calculation, so 4 core 240 square copper except cable value is reduced to 243.5 amperes. So now we will find how many cables are required for the matching our load 729 amperes. That is very simple. So number of runs divided by equal to total load 729 divided by after derating value 243.5. So it came 3 runs is needed to support the 725 amperes. And see these three numbers we are finded without any safety margin. So safety margin means nothing but very simple. um, we consider the cable along with the derating factor, that is okay. Suppose this cable we are going to use for another 10 years or 20 years, okay. So we need to consider additional one more factor, that is called aging factor. Suppose if you are not consider the aging factor, there will be chance of during the 10 year of operation, continuous operation, the cable insulation will be get failure. So you just added the safety margin, that is 20% extra to that derating factors, then it will be sufficient to keep the cable for another 10 to 20 years without any aging factor issues, okay. So for that what I did, I just find the values, that is a 730.5 ampere. I got it from three numbers of cable. If I run with the derating factors, it came 730 amperes. So additionally, along with the 730 amperes into 20% margin. So 20% means 0.2 you have to multiply, or just 1.2, that is a 120% of these values. That came 876 amperes, okay. So now I need to find number of cable runs required for this total 876, because previously load only 729. After I added the 20% of margin, it came as 876. So 876 divided by this 243, this derating factor. So now it is came 4 runs is required. So this is the perfect calculation. So we need 4 runs of 240 square mm copper XLPE armor cable to carry the load of 729 amperes for the year of 10 to 20 years without any issue. So the first condition will be satisfied. So now we will going second condition, that is the voltage drop. So voltage drop is very simple. You just use this voltage drop three phase formula, √3 I r cos theta plus x sin theta, length into 100 divided by voltage into number of cables. So you can see here I is the full load current, R is the resistance of the cable, cos pi power factor, X is reactance of the cable, sin pi is the reactive power factor, and distance of the cable length, and voltage now 440 volt rated voltage of the cable, and N is the how many cables you are connecting. You just put these values in this formula, you will find the voltage drop. This value you can easily get it like full load current, you know how much full load current, 729 amperes for the MCC. Similarly distance 25 kilometers, 25 meters you will know, and voltage 440 volt you know, and number of cable for 4 runs you know. But this R and X, resistance and reaction, you don't know. This resistance and reaction you will get it from the cable, which cable you are using, that cable manufacturer data sheet you have to refer. See here, this is the cable data sheet. From here you have to choose how many square mm. This is a 240 square mm, and AC resistance value for single core and multi core. I am using multi core because it's a 4 core cable, so I am going with the multi core. And copper or aluminum, I am using copper. So I will go here and match the both the values, 240 and multi core copper values 0.0989, that is for the resistance value, R value 0.0989. Similarly X reactance value, see here AC reactance multi core 240 square mm 0.071, so 0.071. And power factor, for the power factor is a cos 9, 0.9 power factor of the transformer. And similarly from the power factor I just find the sin pi value 0.43, and distance is 25 meter, I converted into kilometer 0.025. So I know all these values now with my hand, so I just put these values to this voltage drop formula. So once I put all these values, I got it the voltage drop 0.023, which is lesser than the 1%. So as per the IEC standard, the voltage drop should be lesser than 3%. So it is more than sufficient. Only 1% is came. So voltage drop also acceptable. So second condition also satisfied. Now the third condition, short circuit withstanding capacity. So short circuit withstanding capacity of the cable should be greater than system short circuiting withstanding capacity. In previous this video we started, I told the system short circuit capacity of the transformer is 30 kilo ohms. So our cable should be greater than 30 kilo ampere, means this cable is sufficient for the short circuit withstanding capacity. How we will find? It's finding with a very simple formula, S equal to I root T by K. S is nothing but that area of the square mm of the cable. I is the current for short circuit withstanding current we need to find. T means it is a time second. As per the standard, we need to consider maximum 1 second, and K is the cable factor. Usually if you are using a copper cable, you have to choose 143 and 96 for the aluminum cable. This is a cable factors given by the manufacturers. It is common for all copper and aluminum cables. So just put these values, S equal to I root T by K. From here we need only I, that short circuit current we need to find. So I interchange the formula I equal to S into K divided by root T. So yes, I know my cable size is 240 and the copper cable, so I put the value 143 and time also 1 second. So finally I got the value is 34,320 divided by root 1. So it came 34.32 kilo ampere. So our system short circuit current is only 30 kilo ampere and my cable short circuit current value 34.32 kilo ampere. It means my cable short circuit is more than that system short circuit capacity. So my cable is sufficient for short circuit withstanding capacity. So the cable is now satisfied all these three conditions: derating factors, voltage drop and the short circuit current. So finally I conclude this project for connecting transformer output to the MCC panel through 4 runs of 4 core 240 square mm copper XLV armor cable proposed for that MCC panel. I hope now you will understand how to be size the MCC panel cable sizing, and if you have any doubt you can write it in the comment. I will clear your doubt, and share this video to your friends so they will get also be benefit with this video. So if you like this video, give it a thumbs up and don't forget to subscribe my YouTube channel. Thank you.